Imagine taking the high-pressure, totally cutthroat vibe of a boardroom pitch, combining it with the literal life-or-death stakes of critical infrastructure defense, and then dropping all of that into a university classroom. Sounds intense, right? Well, that's exactly what I found going on at George Mason University's Cybersecurity Engineering Department. Just look at this quote from Professor Alexandre Barreto. Crude or blunt critiques are often the most valuable for engineering growth. I mean, he's absolutely right. In the real world, a flaw in your system's architecture doesn't just mean a bad grade. It can mean a catastrophic breach of highly sensitive healthcare data. Sugarcoating a vulnerability helps absolutely no one, and this entire environment is engineered to reflect exactly that harsh reality. Okay, let's dive into this and walk through our game plan for this explainer. First, we'll look at the Cyber Shark Tank itself. Second, the technical investor mindset. Third, the evaluation criteria. Fourth, we're going to spotlight some really incredible healthcare capstone projects. And finally, we'll meet the architect behind it all. All right, Section 1, the Cyber Shark Tank, bridging academic theory and real-world practice.
So, for their CYSE 587 capstone class, these grad students aren't just handing in a boring final paper. No way. They are stepping into a simulated, high-stakes crucible. Each engineering team gets exactly 20 minutes to pitch their project, justify their complex architectural decisions, and prove their system's worth. And they've got to do it live, defending their technical logic against a panel of senior stakeholders who are literally there just to poke holes in their reasoning.
Moving on to Section 2, the technical investor mindset, evaluating beyond the profit margin.
Now, what's really interesting about this slide is the stark contrast. Who exactly are these students pitching to? The judges here are asked to adopt the role of a technical investor, but forget your standard Silicon Valley venture capitalists who only care about, market size and profit margins. Instead, these judges use a cybersecurity canvas. They are laser-focused on evidence-based security, looking purely at problem framing, harm prevention, and massive risk reduction. The students have to adopt an entrepreneurial mindset for sure, but they have to apply it strictly to systems engineering.
And this completely flips the definition of value on its head. When these students are up there pitching, they aren't talking about financial ROI. In this room, value literally means risk reduction. It means preventing harm and improving trust for highly sensitive environments like healthcare. They're solving the deep operational pains that come from relentless cyber threats. Part 3, the evaluation criteria. Basically, the rules of the room. So these judges don't just go off a gut feeling. They follow a brutal 5-step gauntlet. Step 1, problem framing. Can the students actually articulate the security pain? Step 2, architecture. Is it structurally sound and feasible to build? Step 3, cybersecurity effectiveness. Step 4, threat and risk reasoning. This is where judges aggressively expose gaps in how students think about attackers. And finally, Step 5, a live proof of concept. Because you can't just talk about it. You have to show the software actively defending against live threats. Section 4, Spotlight on Healthcare Capstone Projects. Defending Open EMR. All the rapid-fire startup pitches we're looking at today target a massive real-world problem, defending hospital information systems, specifically Open EMR. Healthcare obviously requires 24/7 uptime, making it the perfect stress test. Our first spotlight project is TrustPulse. Small clinics are required by HIPAA to record system activity, but they totally lack the resources to understand raw audit logs. TrustPulse acts as a standalone oversight engine using read-only interfaces, which means absolutely zero disruption to the daily workflows of the doctors and nurses. And this brilliantly illustrates how deep the engineering actually goes. TrustPulse doesn't just act like a data vacuum. It uses frameworks like Stride to identify different types of threats, and Dread to score exactly how risky those threats are. It even leverages probabilistic Bayesian and fuzzy logic models to detect sneaky access patterns or insider threats. Then it packages all this complex math into a simple human-in-the-loop review interface, so clinic managers can maintain rigorous oversight without needing a PhD in cybersecurity. Next up, we've got PatchEMR. This one tackles a truly terrifying vector for hospital data breaches: unpatched systems. I mean, you can't simply shut down a hospital server for an update when patient lives are literally on the line. PatchEMR acts as an external layer that monitors for weaknesses while guaranteeing a no-downtime patching strategy, keeping the absolute integrity of the system code intact. To pull this off, the team built a seriously sophisticated mechanism. PatchEMR retrieves system images and performs deep component scanning using industry-standard tools like Trivy to hunt for known flaws. It then uses an AI threat broker to translate that complex vulnerability data into simple, actionable summaries for executives. Finally, it enforces strict access controls to push updates seamlessly. It perfectly bridges the gap between finding a vulnerability and actually keeping clinical operations safe. Get this, the concrete engineering goal for Patch EMR is honestly staggering, an 80% surface rate. They aim to handle and mitigate 80% of known vulnerabilities within just 24 hours of discovery. Achieving that kind of turnaround time without taking hospital systems offline, that is an incredible value proposition for any technical investor.
Our third spotlight project is EverWatch. This tackles the massive struggle of delayed detection. You see, hospitals generate vast oceans of data every single day, and security teams simply can't parse through it fast enough. That means privacy violations can go unnoticed for months. EverWatch is designed to provide proactive oversight to catch these issues immediately.
Operating strictly through read-only access, EverWatch acts like a digital bloodhound. It correlates system activity. If someone is bulk viewing records or accessing data off hours, the system flags it instantly. It prioritizes the actual risks and generates plain language summaries. It strengthens the entire hospital's trust boundary and compliance posture without ever having to modify the underlying EMR architecture.
Finally, Section 5, the architect, blending warfare research with infrastructure defense. So, the crucial point is that an intense, high-stakes environment like this doesn't just spring out of nowhere. It comes from the mind of George Mason University Associate Professor Alessandro Barreto, and when you look at his background, the intensity of this class makes perfect sense. He's an expert in air traffic and air defense infrastructure management. He is actively developing applications to fight cyber warfare. He's literally taking the brutal lessons learned from defending life-saving infrastructure from state-level attacks and injecting them directly into his classroom. His teaching philosophy is captured perfectly right here. The objective is to challenge their assumptions and push them to refine their ideas. This isn't about memorizing textbook definitions, you guys. It's about transforming brilliant students into battle-tested engineers who can stand in a room, face intense scrutiny, and confidently defend systems that protect our lives.
Which leaves us with a pretty provocative question. Watching these students apply rigorous threat modeling to zero-downtime architectures really makes you think about the systems we all rely on every day. If your organization's defenses or your patching strategies were thrown into the cyber shark tank today, right in front of a panel of investors demanding concrete harm prevention, would they sink or swim? Thanks for joining me for this explainer. Keep questioning your assumptions, and I'll catch you on the next one.